Hello friends, this is my first video on the subject of calculus. Friends, I have referred book of Gilbert Strang for this subject. Even for linear algebra, I have referred of same author, Gilbert Strang, linear algebra. Friends, he is very good professor also. I have a picture of this book. Okay, this is the book I have referred. This is even a very good book to start calculus also. Okay. You can start from the zero by referring this book. Okay. Now just start. Our first topic of the subject is introduction to calculus. Friends, I have started with very simple example. Okay, driving a car. This example will help you throughout this subject. So please understand this problem. Okay. This is a very interesting example also. Driving a car. Friends, we have two meters on a car. One is speedometers, which records the speed of our car. Okay, and here I have written in kilometer per hour. Okay, and another meter is odometer. Okay, which records distance traveled by a car. Okay, which is I have written here in kilometer. Friends, these are two simple meters. Now I want to find out velocity. Okay, these two things depends on, okay, each other. Suppose I want to find out distance, okay, from the record of v, and second question is I want to find out velocity from the record of this distance. Okay, these are the two basic question, okay, which we have to answer in this subject. Just a second. Okay, I have written these two question. Okay, central question, these two. Okay, finding out distance from the record of velocity and finding out velocity from the record of distance. This first question is answered by differential calculus. Okay, the and the second question is answered by integral calculus. These are the two parts of this subject, calculus: differential calculus and integral calculus. Okay, we'll first further differentiate these two parts. I think you understood what is the main problem. Okay, we, we, we want distance from the record of velocity, and we want velocity from the record of distance. Friends, here I have drawn very two simple graphs. Okay, one is of the speedometer and the second is of the odometer. Okay, uh, one is related to the differential calculus, second is related to integral calculus. Okay, speed. How can I find out this? Just first look at left hand side, means v graph. You will see here I want to find out distance from this graph. Okay, how can you find out v? Just a second, I want to choose a color. Okay, v, velocity is nothing but distance traveled by time. Okay, it means distance is nothing but velocity into time. Okay, here velocity is constant throughout the time. Okay, which is 60, and suppose I want to find out velocity at 4. Okay, that's why, sorry, distance at 4, that's why 240. Okay, which is nothing but also area of this graph. Okay, area under the V graph is nothing but a distance. This is a very important thing. Okay, area under V graph is distance. Please remember that this is a very important thing. Okay, and now we will move to the right hand graph. I have a straight line of the distance throughout the time. Okay, f equals 60t, and I want to find out speed at any time. Okay, in general speed depends on time to time, but here our speed is constant. Okay, because graph of f is straight line. Okay, how can you find out speed? Speed is nothing but distance upon time. Okay, v equal to f divided by time. Consider f at 60, which is nothing but 240, and at what time? At 60, which is nothing but just a second, okay, at time 4, and our answer is 60. Okay, even at 2 also our velocity will be same, because it is straight line. Okay, and this 60 is nothing but slope of this straight line. Okay, slope is 60. Please remember that slope of f graph is speed. Okay, these are the two important points. Okay, area under the v graph is nothing but distance. Slope of f graph is nothing but a speed. Okay, one is answered by integral calculus, second question is answered by differential calculus, or like this. Think you understood what I mean. Now we will see function, meaning of function. I think everyone knows that, but we will role of function is very important in this subject. Okay, that's why function is nothing but a simple equation to which we will supply input. Input in the sense of we will put value to the parameters. Okay, for start with the example, suppose f equal to 60t, it is nothing but simple function, and we will put this t is variable. Okay, and we will supply value to this variable. Okay, to t. Okay, suppose to t equal to 2, that's a 60 into 2 equal to 120. Okay, uh, this t, okay, value which we will put at the place of t is called as domain. Okay, which are nothing but input to the function, called as domains here. Okay, input to the function are, and the answer that we will get after putting this value is nothing but a range. Okay, f, this is nothing but a range, or output of the function is nothing but range. I mean outputs. Commonly it is called as a domain, or commonly it is called as outputs of the function is called as range. Okay, now I have written very simple example of the function. uh, I have choose a straight line. Okay, of the function ax plus c. This is a general form of the straight line, and for example f of t is equal to 2t plus 1. See here, this is a simple graph. What I have done here, uh, subtracted 2 from the range. Okay, in first graph I have subtract 2 from the range, means f of t minus 2. Okay, see here we'll get this new equation 2t minus 1. Okay, it directly affects the range because we are subtracting directly from function f of t. Okay, and in third graph, okay, this is a third graph. Here we have subtracted 2 from directly from the domain. Okay, that's why it affects the domain. These are the very simple basic example how range and domain gets affected. We will have very important application of these terms in our future topics. Okay, now similarly what I have did here, just see same function here. I have multiplied 2 to that function. Okay, it will directly affect the range and also the slope of the graph. Okay, see here slope will get double 40. Okay, here I have directly substituted 40 instead of t. Okay, see here slope will get affected. That's it. Here slope will affected in previous example. Slope is same. Okay, see slope will not get affected. See, that's it for today's point. Okay, we'll see more interesting things. Calculus is very interesting and exciting subject. Okay, we'll see more in next videos. Thank you. Hello friends, this is my first video on